The areas of kites and rhombuses. As seen in all the shapes studied so far, it is important to multiply dimensions that are perpendicular. In a kite, the perpendicular dimensions are not along the outside of the figure, but rather on the inside. And that'll also be true for the rhombus. Now, technically, it is possible to have right angles along the edge of these figures. In a kite, you can have perpendicular sides at the non-vertex angles, but that would be a rare case, and we might not want to necessarily apply that to calculating the area if we can come up with another general way of doing it. In a rhombus, you could also have right angles, but if you had right angles in a rhombus, then it would actually give you a square, and again, that would be a very unique situation. So in general, the perpendiculars that we're going to be using for the figures are going to be the diagonals, which we're going to refer to as D1 and D2. Okay, so here's a picture of a kite. We have two pairs of consecutive congruent sides. So that side is congruent to this one and they're consecutive. This side is congruent to that one and they're consecutive. In a general picture of a kite, you don't get right angles on the edge. But the two diagonals of the kite will be perpendicular to each other. So we could go ahead and use that. We can use the fact that this is a right angle. Then it comes down to using that perpendicular to create a product which we can use to calculate the area. The trick to doing that will be to cut this apart. Okay, so I have a second kite. This I'm going to leave intact. The other one I'm going to go ahead and cut apart so that I can rearrange the pieces in such a way that it mimics a shape who we already can calculate the area for. Okay, I'm going to first cut it in half, like that. Then second, I'm going to take this one and I'm going to cut it along the diagonal. So these are the only cuts that I'm going to need. Okay, this piece is congruent to that piece. What I'm going to do is flip it over. It's kind of the trick there is to flip it over and see that what would be called the hypotenuses match up perfectly. Then the other one, flip that over as well. See if I can scoot it up a little bit higher for you. Okay, and if I arrange the pieces like that, the areas of the two figures that I have, the area of this kite and the area of this rectangle, that will actually create a rectangle. Remember that you've got right angles in all these corners, so that would be a right angle. That would also be a right angle as well. The areas of these are going to be congruent to each other. So I can really just look at this one and think about how the diagonals are used to figure out how the area would be calculated. And here, the width of the rectangle is going to be half of the length of one of the diagonals. The height of the rectangle is going to be the length of the other diagonal, which we can see on this side here. So you've got one diagonal multiplied by half another diagonal. So overall, the area formula for a kite is going to be 1/2 D1 times D2. And it doesn't matter which diagonal you use as D1 and D2. Overall, this is just a product, and you can rearrange those numbers however you want, and you still get the same answer. So we're just going to state it this way. It is half the product of the diagonals. For example 1, let's go ahead and calculate the area of this kite. Notice that it does not specifically state that this is a kite, nor does it have any markings in the figure that would indicate such. It does not show us that KL is congruent to KN. It also does not show us the perpendicular here, or that LM is congruent to NM. But because we are looking at the area formulas of kites and rhombuses, let's go ahead and make the assumption that this is in fact a kite. Okay, so if it is, we can calculate the area by using 1/2 the product of the diagonals. Okay, and again, it doesn't matter which one is D1 and which one is D2. We've got this diagonal here because you have the 3 and the other 3. So we're looking at 1/2 times 6. 3 and 3 is 6. The other diagonal, that tells us we got a length of 2 here. This is a length of 5. So you're going to have a 7. Okay, so the area is literally going to be the product of those three numbers. As mental math, if you want, you can go ahead and divide the 6 by 2. That'll just drop it to a 3, and then 3 times 7 will give us 21. So we get 21 meters squared. For example 2, we're going to calculate the area of the figure that is shown here. Technically, this figure is referred to as a composite figure because it is made out of other shapes. What we have here is a kite in the middle. That does have the correct markings on it. It does show us that these two sides are congruent, these two sides are congruent, consecutive congruent sides. Tells us that we have a kite. In addition to that, the shapes that we have on the sides here are going to be congruent trapezoids. They're congruent because they all have the same measurements here. Trapezoids, because you have the marking here to indicate that these lines run parallel to it. What I'm going to do is go ahead and break up the figure using the lines that are already here. Break it into a couple of trapezoids and the kite because we are actually studying kites right now. However, there are alternative approaches, and when I'm done with this one, maybe I'll describe one that you could use. Okay, so we can think of this as having two trapezoids, and sometimes I do these things called shape equations. Okay, so I've got two trapezoids, which sort of look like that because they're right trapezoids. So I'll go ahead and draw it that way. I've got two right trapezoids, and I'm going to need to add on the kite that would be in the middle. Okay, to calculate the area of the trapezoids, each of those will be 1/2 the sum of the bases times the height. Okay, that would be one trapezoid times 2. We also have the kite, which is going to be 1/2 diagonal 1 times diagonal 2. And what's neat about this is that it shows us all the values that we need. And if we can get all of those values from the picture, then we can complete this expression and have an answer. So with respect to the trapezoids, which are congruent because all the markings are the same, the bases are going to be 6 and 4. So we've got 2 times 1/2, which that's going to cancel in just a bit anyway, but I'm going to keep writing it for now. We're going to have 6 plus 4. The height is that 3. Okay, then for the kite, we've got 1/2 the product of our diagonals. This diagonal here is shown to be 10. The other diagonal would be right here, not given to us, but this length here is 12, and we've got 4 and we've got 4, so that would also need to be a 4. And of course, the shape that we have up here all together, because the sides are parallel and you got that right angle, is a rectangle. It does fit that definition. Okay, so if we calculate all of this, we're going to be good. This will cancel. 2 divided by 2 is 1, it's out. 6 plus 4 is going to be 10, so you got 10 times 3. Of course, that's 30. Over here, you could divide either of these two numbers by 2, which would just be using the 1/2. So let's just go ahead and call that a 5. So we got 5 times 4, which is going to be 20, which all together will be 50 yards squared. As stated beforehand, I'm going to give you a second option that you could use here. The second option that I identified, and there's probably a lot of other ones that you can think of, but the second option that I identified was to look at this as a rectangle and look at this part as a triangle. I could look at it as a rectangle plus a triangle. The rectangle has the dimensions of 12 by 3, which will be 36. The triangle is going to be 1/2 the base times the height. Okay, and we're only looking at this part here. Okay, only looking at that part. The base of that we had previously figured out, I'm going to call that the base there. We had previously figured out in the other problem to be a 4. Okay, and then the height of this, the height that we have here is not going to be 10 because 10 will go from here all the way to that spot. So if we subtract 3 from 10, we get 7. Oh, those numbers would actually just gone there as well. Okay. And then right here is where I wanted to simplify a little bit. Half of 4 is 2. 2 times 7 is going to give you 14. Or you could say this is 28 divided by 2 gives you 14. But look, 36 plus 14 is 50. The exact same answer you get there.
Later, Brah.